Hello, mathletes. It's Miss Rhodes back again to talk about the vertex and axis of symmetry of quadratic functions. As a review from your previous day's work, a quadratic function is a function that can be written in the standard form y equals ax squared plus bx plus c, where a is not equal to 0. Every quadratic function has a U-shaped graph called a parabola. If the leading coefficient of a, so that is the coefficient of x squared, if it is positive, our parabola opens up. So it looks like this. If our leading coefficient a is negative, our parabola is going to open down. So it is going to look like this. The constant c is very similar to our linear equations, where our constant is our y-intercept. And so this does not change in quadratic functions. So your number that is alone, or your constant, is your y-intercept. The vertex is either our lowest point or our highest point at a parabola. So if it opens downward, our vertex is here. If it opens upward, our vertex is at the top. The line that passes through the vertex that divides our parabola into two symmetric parts is called the axis of symmetry. And as a side note, our axis of symmetry is always going to be a vertical line, which is straight up and down, so you should know that that's an x equals line. And we'll see from the two examples how that is true. Finally, number 8, solutions of quadratic functions can also be called x-intercepts, zeros, or roots. So again, we have 4 different vocabulary terms that can be used. Can ask for solutions, x-intercepts, zeros, or the roots, not the band. Next, we're going to see how to find the vertex and axis of symmetry when we are given the equation of a line. So the first step is to put our quadratic function into standard form. So y equals ax squared plus bx plus c. So looking at example 1, I see that my y is isolated, and then it is in the form of equals x squared, x, and then my constant. That way it's easier for us to identify our numeric values. So my a, or my coefficient of x squared, is -2. My b, coefficient of x, is 4, and my c is a -9. So now that I have my a, b, and c values, I can find the vertex, or the x-coordinate of the vertex, by using x equals -b over 2a. So if I do that, x equals negative, and then my b value, which is 4, all over 2 times a, which is -2. So that leaves me with -4 over -4. And then when we reduce that, that gives us 1. So I know that my vertex, or my x-coordinate of my vertex, is going to be 1. Step 4 is I'm going to substitute my x value into my equation at the top to find out what my y value is. So my y equals -2, then my x squared plus 4 times 1 minus 9. And when we put that into our calculator and we solve it, that gives us y is -7. So now I have my vertex, my x value, and my y value. So I have 1, -7. And my axis of symmetry, which cuts my parabola in half, if you will, is just x equals, and the x value of your vertex, which is 1. Finally, we have if it opens up or downward, which can be easily identifying by looking at the coefficient of x squared. So that's -2. So since it's negative, it's going to open down. And my y-intercept, again, we look for our constant, which is -9. We have one more example that I'm going to rock out with you, and that is going to be an example where we need to do step 1, which is get our y alone. So I see I have y minus 5, so I need to move my -5 over. So I do the opposite operation, so +5 and +5 on both sides, which that leaves me with y equals x squared minus 11x plus 24. Now, step 2, I'm going to identify my numeric values of a, b, and c. So my a, my leading coefficient of x squared, is the invisible 1. So it is a positive, so positive 1, so we can already say that it's going to open upward. My b value, or my coefficient of x, is a -11. And then my c value is going to be +24. So we also know that our c, which is our constant, is our y-intercept. So we know that the y-intercept is at 24. So now I can find my vertex. So I have my y equals, or x equals, negative, and then I look for my b, so the opposite of -11 is a +11 over 2 times a, which is 1. So I have 11 divided by 2, so I'm going to use the decimal place 5.5, or decimal 5.5, and that's okay. So my x value is 5.5, and then my y value, again, we're going to plug in to our equation. So I have y equals, and then I have 5.5 squared minus 11 times 5.5 plus 24. And when we put that in our calculator, it gives us -6.25. So that is our y value. So our vertex is at 5.5, comma, -6.25. Finally, our axis of symmetry is always going to be our x equals line, because it's going to go up and down because it's got to cut our parabola in half. And it's going to be the x value of our vertex, which is 5.5. So now that you've gone ahead and looked at these 2 examples, it's time for you to rock out the 6 problems plus the exit ticket on the back. See you soon, mathletes.